Good morning from the Great Lakes State, and welcome to the annual Great Lakes Virtual PFAS Summit. Very excited to have everybody back this year. My name is Mike Gurney. I am the Michigan Department of Environment, Great Lakes and Energy's Remediation and Redevelopment Outreach Specialist. You'll see a lot of me this week, for better or worse. I'm excited to welcome you all today to this PFAS 101, 10 things to know about PFAS as we get started on our week-long journey here together. So I'm going to introduce Mike Jury, MPART Michigan PFAS Action Response Team, PFAS Specialist, and Abby Hendershot is the MPART Executive Director here in just a second. I've got a couple intro slides to hit here this week. You'll see these pretty often as we cover this information to start each session this week. So we are recording this webinar. These recordings should be available online very shortly after the end of every day. I'm going to work very hard to get these posted as soon as possible. You can go back and watch these at your leisure. Make sure folks know if they missed a session, they can come back and watch these anytime. All lines are muted during the webinar, so you can hear us, but we can't hear you. We would like to remind you, though, we do want to hear from you, right? So ask your questions throughout the presentations this week. Ask your questions throughout the presentation today. You can use the Q&A box in your Zoom toolbar. So you can click on that and ask your questions there. Or you can go through Whova. And the nice thing about Whova is if we don't have time to get to all of the questions, those questions in Whova will remain throughout the week, and speakers and other attendees can engage throughout the entire summit and answer questions and keep the conversation going. So if you don't have a chance today during the sessions to ask your questions, go into Whova and engage with presenters there. With that, oh yeah, I don't have my little break slide in there, so I'll have to add that see, we're learning together. So I will stop sharing. I will allow Abby to share slides, and Mike, go ahead and take it away.
Great, thanks so much. I'm Mike Jury. I'm MPART's PFAS specialist, and I'm going to talk to you today about 10 things to know about PFAS. There's probably more than 10 things in here, but we've got them put together. So thank you very much for attending. Abby, who is running the slides, go ahead and go to the next one. And so we're going to cover PFAS basics. That's our number one. So it's kind of like the top 10 things that you might want to know about PFAS. So next one, please. So the starting point for PFAS is electrochemical fluorination. And 3M came about this idea of taking liquid hydrogen fluoride and then zapping it with a current, a small voltage and current, and they were able to make PFAS. So they patented this back in 1948. So that's our start of PFAS. Go ahead, Abby. So we're going to talk a little bit about PFAS chemistry. And as you know, if you've dealt with this at all, it's like alphabet soup. There are so many different combinations of PFAS out there, all with all their initials. So just think about it like alphabet soup. Go ahead. Next, please. So what are PFAS? Well, they have strong carbon and fluoride bonds. They're the most strong bonds they are. They're surfactants. They're highly stable. That's why they're used. They're unique in that they can repel water, oil, fat, and grease. They were started, as you saw, back in the 40s. There are thousands of compounds, PFAS compounds today, and depending on how you define them, there could be tens of thousands, hundreds of thousands, or millions of them. So why are we concerned about them? They are widespread throughout our ecosystem, water, soil, wherever. They don't break down easily, and they're hard to get rid of. They bioaccumulate. They could build up in our bodies. They certainly do bioaccumulate in fish and other animals. There is evidence that PFAS may affect health. There are some emerging science and information on it. And obviously, there's always a need for federal standards so that we don't have 50 different standards from 50 different states. So next one, please, Abby. So one of the things I want you to get out of this, and hopefully this will stick with you forever, that PFAS molecules have a head and a tail. So how can we remember that? Remember a duck or a goose diving, its tail sticking out of the water, head down in the water. So the tail is fluorinated. It's hydrophobic, meaning it doesn't like water, while the head on it is hydrophilic, does like water. So there's a functional head. So this is the PFOA molecule. So it happens. We replace the hydrogens with fluorine, And as we said before, it's a very inert, very strong chemical. It does resist thermal, chemical, and biological degradation. It can be done. It takes a lot of energy to break that bond. It is a surfactant which reduces surface tension of water. So once again, thing to remember, PFAS has a head and a tail, and the head likes to be down in the water, the tail likes to be out. Next one, Abby. So it's all in the name. PFAS, when we say PFAS, we mean the entire family of PFAS chemicals. As we said, there could be hundreds of thousands, millions, all depends on how you define it. So PFOS and PFOA are two members of that family of all the PFAS. So one of the things that I always recommend that people, when they're talking about PFOS and PFOA, pronounce PFOS with a long O, and then people will remember. And PFOA reminds you it will rhyme with lawnmower or NOAA. So PFOA and PFOS. That'll help people understand what you're saying versus PFAS, PFOS, whatever. So they're two chemicals out of the whole PFAS family. So go ahead, Abby, to our next slide. So PFAS uses. Where is PFAS used? If it's such a big deal, where is it at? So in the 1930s, there was a chemist for DuPont who was working on fluorocarbon refrigerants, and he filled a pipe full of a PFAS, not PFAS, but a fluorinated material. He came back the next day and there wasn't gas in the tube that he put in there. He opened it up and found Teflon. So he accidentally found Teflon in 1938. So in the 1940s, it got used, Teflon that is, got used an awful lot in the Department of Defense Manhattan Project. You needed to have a compound that was very resistant to uranium hexafluoride, a very corrosive gas. So Teflon was used a lot in the Manhattan projects. We move up to the 1950s, and for those of you who are older, you might remember a pan called a Tefal, and that pan stood for Teflon and aluminum. So we start getting this stuff used in consumer products. We jump into the 1960s, and we get aqueous film forming foam, AFFF, firefighting foam, developed by 3M for the military. Next one, please, Abby. In the 70s, it just goes wild. We get PFAS in everything, all kinds of consumer products, personal care products, manufactured items, just everywhere. In the 2000s, we start finding PFAS around the world. We find it in the Arctic ice cap. We find it in polar bears. We find it in the ocean. We find it in birds, mammals. We find it everywhere. Till we get to today, and we have a lot of public scrutiny on PFAS. The regulatory climate changed. There are lawsuits, plenty of lawsuits out there. And along the way, we're developing new PFAS to meet other needs. So next one, please. So there's also a PFAS timeline. You can see Teflon was invented in the 30s. Then we went to nonstick coatings, waterproof fabrics. PFOS, you can see 1940s using electrochemical fluorination. We end up with it in the 50s using for stain and water resistant product. You might remember Scotchgard, which was a 3M product that was used a lot. 60s, we get the firefighting foam. And PFOA gets into protective coatings. So you can see that PFAS used in a lot of different places and a lot of different ways. So next one, Abby. So what we did is we put a house up. Where would you find this in your house? Well, you might have waterproof or stain-resistant clothing, coats, pants, shirts. Your carpet may have been treated with PFAS for stain resistance. It is in personal care products, things like cosmetics, shampoo, hand cream. And so we find it over in our bathroom area, in household cleaners you might use. It also can be used in aerosol cans, carpet cleaning. Going down, we find it in finishes and furnishings. So your furnishings may be coated with Scotchgard or some type of Teflon repellent. Then food packaging, of course, the famous microwave popcorn bags that had PFAS in them. Nonstick cookware, PFOA was used in nonstick cookware an awful lot. And then over on the right, we find outdoor gear where we need things that are waterproof, stain resistant, strippers, children's car seats. Uh, Children tend to be messy. If you have kids, they like to dump stuff in their car seats and whatever. So car seats have been treated. Sealants used outside, our automobiles are full of PFAS. So if we can go to the next one, please, Abby. So some of the other uses, aerospace, there's a certain PFAS chemical used in hydraulic fluid in airplanes. It's used in apparel, all kinds of products in building and construction, whether it be paints, varnishes, sealants, coatings. Chemicals and pharmaceuticals. There are PFAS in pharmaceuticals and the chemicals, the packaging. Your cell phone, yep, wouldn't have been made without PFAS being used and PFAS in the product. Oil and gas, you've heard about fracking. Sometimes some of the chemicals in fracking use PFAS. Energy, the solar panels may be coated with a PFAS compound to take care of dust and also repel rain and snow. Many products that we use in healthcare and hospitals are PFAS based. Obviously, the aqueous film forming foam or AFFF, that's a big source. And semiconductors. You can't make semiconductors today without using PFAS. It's a critical use item in making semiconductors. So next one, please. Okay, so we have a general understanding of where it might be used. How is it that we are exposed to it? So how are we exposed? One of the major ways of being exposed to PFAS is by drinking contaminated water. Another way would be to eat fish that come from water that is contaminated with PFAS. For Michigan, and we realize we have people from around the United States and the world listening in on this. Michigan has Eat Safe Fish guidelines that helps a consumer, a fisherman, fisherwoman, understand what's a safe amount of fish I can eat from this water body. So we have guidelines for different lake streams and the Great Lakes in Michigan that tell you what recommended amounts of fish you can eat out of that body of water. You might get it from incidental swallowing contaminated soil or dust inside your home. Unfortunately, the dust in your home contains PFAS. You could get some from eating food that's been packaged in materials that contain PFAS. A lot of the cardboard paper materials that are used in packaging of food, people don't really like to have oil stains or grease stains on their packaging of the food. It might make you think, well, this couldn't be good food because it's got the grease coming through. So the manufacturers can put PFAS in those packaging materials so grease and oil don't stain the packaging. Consumer products, personal care products, shampoo, hand cream, cosmetics, a lot of different things have PFAS in them. Fortunately, PFAS absorption through the skin is typically not a concern. So if we can go to the next one, Abby. So PFAS exposures, PFAS in health. And I will start this out. I'm not a doctor, I'm not a toxicologist. So keep that in mind. So what are some of the things that can happen with human health outcomes? We can have reduced fertility, high blood pressure, preeclampsia in pregnant women, and sometimes small decreases in infant birth weight, higher cholesterol, especially total and LDL. So next, please. Thyroid disease, liver damage, decreased immune system response to vaccines, and some types of cancers, and especially ones that are caused by PFOA exposure. So there are definitely associated human health outcomes from PFAS exposure. Citizens in the United States, we test their blood in a national study and we find PFAS in their blood, and it is going down over the years. So another way is PFAS in food. So the FDA, the Food and Drug Administration, does test a variety of foods as part of their total diet study. And the FDA has found no indication that PFAS at the levels found in the limited sampling of foods present a human health concern. And so the highest concentrations of PFAS found out there was in seafood, which makes sense because the oceans and waters around the world do have PFAS in them. So if you're interested in this, I would recommend that you look at the FDA website, and they have a lot of information on the testing they've done on PFAS in food and dietary exposure. So next, please. So PFAS in fish, we did talk about that. Fish living in contaminated water can have high levels of PFAS in their bodies. Now in Michigan, we Eagle partner with the Michigan Department of Health and Human Services and also the DNR to sample fish throughout Michigan water bodies. And that could be lakes, streams, it can be the Great Lakes. So we test them for PFAS, heavy metals, mercury, PCBs, and some herbicides and pesticides. So fish in Michigan get tested an awful lot. And the recommendations that we make based on the samples we've taken are in the Eat Safe Fish Guide for Michigan, and there is a link there to that. So if we can go to our next one, please. The PFAS cycle. This is Abby's favorite slide and one of mine also. So we're going to start up at the top left about PFAS producing industries or industries that use PFAS. And so maybe we're making widgets, we're making gaskets, we're making something that may contain PFAS, or PFAS is used in the process. So we can have groundwater released from our factory. We might have wastewater that was directly discharged to the stream. In most cases, our wastewater goes to the wastewater treatment plant, which was unfortunately never designed to take PFAS out of the water coming into the wastewater treatment plant. We end up with a direct discharge to a stream, a lake, a river from the wastewater treatment plant. We can have the sludge that goes to a landfill because the sludge from the plant has to go somewhere. So it might go to a landfill. It might be reused as biosolids going to a farm field. And so we also have air emissions from our factory. So that we take a look, and the air emissions can go to the residential homes. We already have PFAS in our residential home through carpeting, fabrics, whatever, and the use of personal care products, cleaning products. When we look at the biosolids can be applied to the soil at farms. We in Michigan, we have a program where we definitely regulate biosolids and look at that and make sure that they're being applied in not only just an agronomic rate, but a rate that's not going to cause problems with food products. So we have food products that go to our residential homes. We drink water, whether that comes from municipal water, which might come from groundwater, could come from a lake or a stream or the Great Lakes. We also have plants uptaking water, which could be contaminated. We also have the materials from the biosolids that could infiltrate into groundwater, make it into our surface water. And if we're at an airport or some other area where we had to use firefighting foam to put out a fire, that certainly can go into groundwater and also can go into lakes, rivers, and streams. So we have the big cycle. We have PFAS over in our one area. And then one of the things we have is we have all of our materials that we throw away that go into the landfill. So whether it's materials from the factory, rejects, or our waste ends up in the landfill, and the leachate from that landfill then also goes to the wastewater treatment plant. And can you see the big circle? The sludge goes back up to the landfill, leachate goes. So we have that giant circle going on there. So once again, as we said, wastewater treatment plants not designed to take PFAS out of water. So in Michigan, we do have a limit on the amount of PFAS that can be discharged from that wastewater treatment plant into the receiving water, whether that be a river, the Great Lakes, or groundwater, wherever it might be. So we do a lot of work with wastewater treatment plants, looking at their discharges and working with them to make sure they're not discharging higher levels of PFAS into the receiving water body. So can we go to the next one, please, Abby? So one of the things we talked about all the different places that PFAS could end up. And so in Michigan, we when the time the slide was put together, we had 296 PFAS sites. We're coming into 300 right now. And so when you see one of the major ones was landfills. Why is that? Well, things go to landfills that contain PFAS. But also, we had a program in Michigan where we looked at landfills, whether they're large, we're on our smaller ones now, looking for PFAS discharges from them. Unfortunately, found a lot of landfills with PFAS problems. Then you'll see the next large category is industrial, and that could be a plant that makes something with PFAS in it, a chemical plant, other types of manufacturing, because PFAS is used in so many facets of manufacturing. You can see platers. Unfortunately, hard chrome platers, plastic platers that use chrome have problems with PFAS. Airports, all of Michigan's commercial airports have PFAS problems from the use of AFFF. Military, we have many military facilities in Michigan that are aviation related. So once again, AFFF from those. Wastewater. Now the plant itself is not the source of the PFAS. It's the materials going into the plant. But once again, we measure what's coming out of it. Fire-related, laundromats and dry cleaners, not a well-known fact, but at one time, your soap that you use in washing your clothes had PFAS in it. Paper manufacturing, Michigan has a lot of people that manufacture paper, and part of it was to make paper that was grease and oil resistant. We have some tannery problems, refineries, and we have some unknowns. So you can see we have a lot of different sources of PFAS in Michigan. So next one, Abby. PFAS in drinking water. We said that drinking water was one of the main ways that you could get PFAS into your body. So let's go and take a look. So you ought to know what's in your drinking water. If you get water from a municipal water supply, that water is tested by the municipality to make sure what levels of PFAS are or are not in it. If you're interested in what is in your municipal water, then you can contact the water system, and they may have it online. They may send it to you in the mail, but if you wish, you could call them and ask them for information. If you get water from a well, guess what? You're your own water company, and you're responsible for taking care of your water system, your well, and all your plumbing and what's going on. You may wish to sample your own water. If you go to our MPART website, we have a spot on there that will give you a list of all the labs in Michigan and a few out of state that can test for PFAS, and you can contact them. We give you a phone number and other information for that. So in Michigan, we do testing of water for PFAS. Now, if you have a well, it's one of those very confusing things. We can't see underground, so we have absolutely no idea of what's going on underground. We have this just graphic to help you get an idea of what's going on. And this graphic was based on a site in Michigan where we have different aquifers, or where we pull water out of. And each one of those aquifers has groundwater flowing in a different direction. And we can thank glaciers in Michigan for all these interesting groundwater flows. So we have some, our shallow aquifer has water moving off to the northeast. The intermediate one has it going to the northwest in one part of the area, off to the northeast in another one, and the deeper one flows to the east, and the deepest one of all goes off to the west. It's confusing. Who knows? It just, one of those things that makes it very difficult in Michigan and other states with glacial geology to try to figure out where groundwater flow is. So let's go to the next one. And so you can have wells in different areas, and depending on where the clay is in that area, you may or may not get PFAS in your well. So we're using a reddish colored plume here, and you can see over on the left, we have a house that has a deeper well, and they're not getting any PFAS in their well, but the well, next well to the right, is picking up PFAS from their well. And then we go all the way over to the right, and because of the clay layer there, the thick clay layer is protecting that deeper aquifer, and that home is not having a problem at all. So if we can go to the next slide. So we end up with these problems, which are very hard for us to explain to residents. So if you look at the left-hand side, we have homes with no detection, and we have a home right in the middle there with a detection that's less than criteria. Then we cross the street. I mean, here we go 50 feet across the street, and we have a whole lot of homes that have exceedances. And we have one home in the middle, once again, that has a detection but less than criteria. So if you remember the slide before, we have different aquifers, we have groundwater flowing in different directions, we have different clay layers. So this makes one of those things that is very hard to understand. Why does my neighbor not have anything in their water and I have problems with my water? Across the street, they got all kinds of problems. I don't have anything going on in my well at my house. So it depends on the geology. It depends on how much clay there might be. It just depends on a lot of different things. So it's a complicated business trying to explain to people why my house has PFAS and my neighbor doesn't. So let's go on to the next one. So what can we do to avoid PFAS in our drinking water? So we don't pull our head back in our shell. We got to get right out there and take care of this. So go ahead, Abby, let's take a look. So one of the ways to deal with this is to get a filter. And there are many different filters out there. There are filters that go under your sink. There can be a pitcher filter. There are whole house filters. What do I use? I might have a filter with carbon. I might have reverse osmosis. I might have ion exchange beds. There's all these different ways. But the main thing that you want to know is make sure that it has the National Sanitation Foundation, or NSF, or ANSI, standard 53. And that means that it has been tested and certified to reduce PFAS, in this case, PFOA and PFOS, to reduce this. And when you install these units, make sure you follow the manufacturing instructions so that it'll reduce PFAS as we expect. The other thing that you need to remember, great, I put it in, it's working, I'm getting water that is lower in PFAS or is non-detect. Remember, you're your own water system. You have to maintain this unit. So you'll be required to replace the filters every so often. And the manufacturer will tell you, we recommend after so many gallons or so many months, you should replace the filter. Sometimes the filters will have a little light or something on them that will change color to let you know it's time to replace the filter. So please remember, you're your own water company if you're on a well. What else can I do to avoid PFAS? Well, you can take a look at what you're using and what you have in your house. Remember, food packaging might have PFAS in it. Pots and pans, especially if we have the old ones that are quote unquote Teflon or other types of coatings in them, they could have PFAS in them. Our carpets and rugs can certainly have PFAS in them. Personal care items, like I mentioned, shampoo, hand creams, other things, makeup, cleaning products, and waterproof and outdoor gear. So a lot of things in our house could expose us to PFAS. So what can we do to make sure that we're not exposing ourselves? So let's go to the next slide and take a look. Always look at labels. Now, labels aren't always the best thing that we can use to take a look at it. So in this case, toxin-free. It's free of PFAS, PFOA, lead, and cadmium. Okay, so it says PFAS. Okay, remember the big family? And it says PFOA, one of the members of that family. Okay, no lead and cadmium. And ceramic pan, okay, nonstick. Okay, no PFAS, no PFOA. And then we come up to other ones up in the right-hand corner, the waffle maker, which is PFOA free, but that doesn't mean there might not be some other type of PFAS in its use. And so we got to take a look at the labels and try to make sure that we understand what it is that is in it. So one made without PFOA, made without Teflon, made without PFOS, but doesn't say there isn't some other PFAS that's in there. So let's take a look at the next slide, please. So we came up with a list that has information for you on PFAS and things in different types of products. So these are different websites that you can go to that talk about different types of things that might have PFAS in them. And so you can see not just one website covers everything. So you may have to go to different websites to take a look and try to find all the different issues out there with PFAS. Now, It's hard for us to endorse products. We can't verify claims made by manufacturers. The only way that we could do that is we'd have to have a lab. We'd have to do a huge amount of testing. And so these things that have been evaluated by third parties, I can't tell you if their conclusions are right or wrong. You have to look at it. You don't need a chemistry degree to figure it out, but these websites will help you get a general idea of what you're looking at and what you're having to deal with. So let's go to the next one, please. So what do we do about this? It's out there in the environment. We have to deal with it. We got to try to remediate it, try to mitigate it. What can we do? What tools do we have in our toolbox? Well, there are some treatment technologies out there, and we're still advancing. There are new entrepreneurs out there all the time coming up with new ideas and new ways to treat PFAS in soil, groundwater, surface water. One of the newer ones is sonication using ultrasound. Think about when you clean jewelry. This is a similar type of thing where we use sound waves to break it down. Plasma technology. No, I'm not talking about plasma from the sun. I'm talking about cold plasma where we use ultraviolet light and use that to break down PFAS. Surface active foam fractionation, or SAF, you might see the abbreviation, is a way to take water and use the property of PFAS to be a surfactant. We blow air through it. It makes foam. We can collect that foam and concentrate the PFAS in that foam. So we might have to run our water through the SAF unit a couple times to do that, but we can get a huge reduction in PFAS in water by running it through that. Supercritical water oxidation, or SCWO as it's known, where the water is at least 374 degrees C and at a minimum of 3,200 PSI. And that is enough to make what we call supercritical water, which can break those fluorine and carbon bonds. Another one that's fairly new is ball milling. So if you think about a power plant where they have to grind coal down to very fine powder, it's been found that you can put dirt contaminated with PFAS in there, and that action of the balls, the pressure and the temperature that you get between the balls and the surface, you end up with a PFAS breakdown. Biochar, think of charcoal-like materials. They can sequester PFAS in that material. So a lot of that's being done is to mix biochar with soil to fix the PFAS in that. They have tried thermal treatment on soil using high temperatures to try to get the PFAS. The temperatures may not be high enough to break it down, but they are high enough to take it out of the soil, make a vapor out of it that we can capture. So let's go to the next slide, please, Abby. So what are some of the treatments? So on the left-hand side, the colors are pilot scale, and then we have full scale. If it's green, it's effective, may achieve some of the goals we're looking to do, and yellow may be effective, and red currently not too effective. So air stripping of water for PFAS just doesn't work real well. PFAS doesn't want to strip out of the water. It's very miscible in water. It's hard to get out. Reverse osmosis will take PFAS out of water. Granular activated carbon, or GAC, as you might hear it, very effective, one of the oldest treatments around to take things out of water. So that works well. Ion exchange resin, once again, works really well, an old proven technology. So soils are difficult. So what can we do with soil that is contaminated? We can excavate it, take it to the landfill. Oh, gee, now we have it in the landfill, and it can come out in the landfill and create a problem there. So it's kind of like transferring one problem from one area to another area. We can cap the soil. In other words, we can put clean soil over the top. We could put a pavement or something to prevent human contact or contact by animals, whatever, with the soil. It doesn't take care of it, but it does prevent exposure to people. Soil washing, where we actually wash the soil to take PFAS out of it. It's working. There are a lot of demonstrations that are going on to show it, but it takes a lot of water, a lot of fluid. So you end up with this water and fluid that you have to deal with later. Stabilization, by that we mean putting biochar, some carbonaceous material into the soil to stabilize the soil and then also get the PFAS to be bound up in that material. There are some companies out there that sell a product that you can inject into the soil. So as contaminated groundwater flows through it, it will take PFAS out of the groundwater and put it into the carbon material. Soil vapor extraction, it's not super effective yet. It's being worked on, and there are promising results from testing that's going on. We're saying it's not effective at the moment, but they'll get there. So these are just some of the treatments that are out there. There are many more, and there are many more companies out there all the time that are coming up with techniques to do treatment. So you'll find a lot new methods coming out on the market as we move along in time. So if we could have the next slide, please. What are some of the resources that you can use to find information about PFAS? So there are many out there. Let's go to the next slide. My favorite, of course, because I work for MPART, is our website. And our website has so much information out there, you will be amazed when you take a look. It will take you some time to get through all the different topics that are out there on our website. So if we go to the next one, please, Abby. So what are some of the things you can find? You can find resources for residents, information about MPART, information about drinking water, all the sites that we have in the state. Oh, I want to sample for PFAS. How do I do that? So we have sampling guides. We have information about the investigations we do. And one of the best things that is out there for citizens is our GIS system, which you can see at the bottom. It shows you where all the PFAS sites are in Michigan. It shows you all the sampling that we have done for PFAS across Michigan. It shows you where we've sampled for fish, where we've sampled for water in lakes, streams, and rivers. So you can see the purple triangles, which are PFAS sites, green squares, which are water sampling, and blue stuff, which is water sampling for drinking water sources. So there's a lot of information there that you can get. So you click on a spot and get all kinds of information about it. It is truly one of the best things that we have done to get PFAS information out to the public. So once again, there is a public meeting calendar out there too, that we have town halls for residents in affected areas where we go and find PFAS in an area. Then we'll have a town hall to help citizens understand what's going on. What have we found about PFAS in their area? So another wonderful place to go is the ITRC website. And this is actually a website that, as I get new employees that are working in the PFAS world, I send them here. This is a great place that will help you understand PFAS, train you. It gives you all kinds of information. There's, depending on how you learn, if you're one that learns by reading, then there is a way you can read all the information. If you like videos, they have videos, but it is a one-stop shop to learn more about PFAS. If you want to learn more, this is a great place to go and find out information. Everything from chemistry to stuff it's found in. There's fact sheets, just a lot of different ways to get you information on this. I can't say enough about this website. This is just great. The people that have put this website together are from industry, from states, from academia, all lines of people working together to get information out there for you to understand PFAS. Can't recommend it enough. So let's go to the next one. So one of the things about MPART is all the different agencies that come together to work to solve problems in Michigan dealing with PFAS. So there's EGLE, there's MDOT. You think about MDOT, MDOT. Oh, well, MDOT regulates airports in Michigan. So airports have PFAS problems. MDOT also has construction sites throughout Michigan where they may have PFAS issues. So we have MDOT working on that. LARA, wow, LARA, licensing and regulation. That's where the state's fire marshal is at in LARA, and our state fire marshal working with fire departments and other agencies on AFFF and other things dealing with firefighting. and our firefighters too. MDHHS, Health and Human Services, those folks do so much stuff on health and things with PFAS. They have all kinds of special projects in Michigan. They're working on a project with firefighters to look at exposures. We mentioned vaccines. They did a study. If you're exposed to PFAS, is your vaccine? What are the responses? So anything dealing with human health, that's where our folks there. DNR, obviously all our wildlife and fish in Michigan. DNR works with us to make sure that hunters and other people that are using wildlife and resources are protected. Michigan Department of Agriculture, absolutely looking at all our crops and animals and things that are used for food in Michigan. And finally, I don't want to forget them, our Department of Veterans and Military Affairs, which is the National Guard is one of the things. And so they have military facilities across Michigan and are working to make sure that those facilities are tested. And also if there's a problem with their facility, they're working to treat and take care of the PFAS contamination at those sites. So once again, all those agencies working hand in hand together to make sure that PFAS is taken care of in Michigan. Abby came on, so now you can see Abby. Abby is the executive director of MPART. And so Abby will have a few words to say, but I think maybe, Abby, should we take questions first? I am sure there are plenty of questions out there.
Yep, I think we're ready for questions. So
Great, thank you. Yeah, both questions in Zoom and in Whova, so I appreciate everybody reaching out. We're doing our best to answer some of these questions, especially in Whova, as folks have time. Feel free to check that out and add to the conversation. So we'll jump into it. We got about 18 minutes here and plenty of questions to go. So one question is, how often are the PFAS in fish tested based solely on muscle tissue for human health versus whole body, which would be helpful for both human health and eco? It seems testing only muscle tissues for PFAS is the norm.
Well, that's a great question. I'll start with it, Abby, and then you can jump in. So one of the reasons we test fish the way we do is, how do people eat fish? So people don't eat the heads of the fish usually, or the tail. So we go ahead and we take the fillets from the fish and we test those portions because those are what people tend to eat. And then it's also easier when we do our Eat Safe Fish guidelines. We use different ways of telling you how many ounces and what a serving of fish looks like. So some fish, we do the whole fish, we'll grind the whole fish up and test it that way. But most of the fish we do is done on the filleting because that's what people eat. Now I'll let Abby speak on that.
the any of the fillet data would be included in the Eat Safe Fish Guide for human consumption. The whole fish data is done for more of the ecological assessment parts of our regulatory programs. And so they do collect whole fish data. It's not included in the Eat Safe Fish Guide, but we do have that available. I don't know if our whole fish data is available on our fish data set. I think it is out there on our MPART website. So the other thing that Mike was talking about with the GIS layers is there are layers for the PFAS sites, the surface water, the municipal drinking water, and then also fish. All of that is open data, and so you can download that. And I believe that the whole fish data would be included in that data set for fish as well. And it'll include a lot more than just PFAS. So just know that when you download that, it'll be PCBs and mercuries and other things besides PFAS as well.
Great, thank you. Aside from producers of PFAS, what specific industrial users has Michigan found to have the highest concentrations of PFAS in their effluent? And then do they have limits that they need to meet?
Well, yeah, that's an interesting question because we regulate what goes out of the wastewater treatment plant, and we look to the wastewater treatment plant to look at what's coming into their system. So we do have a lot of industries in Michigan that have PFAS uses, and we have found PFAS in a lot of different things. Abby's bringing up our thing. So yeah, there are a lot of different types of things, industries that have PFAS in them. And in many cases, the company may not even know that they have PFAS in their products that they're making. They'll get a chemical in, and it may not say that it has PFAS in it, or it's such a minor amount. But if you use enough, you multiply any small number by a big number, and pretty soon you have a bigger number. So, yeah, it's out there. And as far as the highest, I'm going to think that platers are very high. We've found very high levels of PFAS in platers, especially PFOS. So other ones too, but thousands of parts per trillion in water going into the wastewater treatment plant.
As far as limits, we do have water quality, surface water quality limits that they do have to meet for discharge. And then if they're discharging through an NPDES permit to surface water body, if they're discharging to a wastewater treatment plant, a wastewater treatment plant may have local limits that they have to meet, or for PFOS, generally they have to meet about 12 parts per trillion for discharge into wastewater treatment plants. So that might vary location by location, but most of the wastewater treatment plants have their own discharge limits. So they're going to ask those industries to meet those limits upstream so they don't have to put on treatment at the wastewater treatment plants.
Yeah, so the industry may be required to put treatment on their discharge to the wastewater treatment plant. And that's happened where they have such high levels that they need to put treatment on. What do they use? A lot of times it's GAC, the granular activated carbon, to take the PFAS out of their wastewater before it gets into the system.
Great, thank you. And to tie into a question we have in Hoover, there was a request for the links that you shared in your PowerPoint, the MPART Consumer Products website, right? Again, like where do we find these things? And so I shared that both in the chat and in Hoover. So that is there. I've tried to post it. If there was a follow-up question to that, feel free to reach back out. How important is residence time in the filter system when trying to remove PFAS with a filter at home?
Wow, that's okay, an engineering question that I'm not going to be very good at, but the oh goodness, the residence time. So you'll see the PET photo that we had of the system. You'll see that there's 3 different canisters on there. So there's usually a lead, a lag, and so the residence time is kind of set by the system itself. So these units may be able to put out a gallon per minute. So the longer the contact time with the carbon or the beads, if they're ion exchange beads, better. But the manufacturer of the system's got it tweaked down so that it goes through there pretty darn slow so that you can get good treatment on it. So what's a time? It's hard to say because it depends on how big the filter is, how much carbon is in the filter, how much pressure is on the water, how fast does it flow through. And I don't think anybody wants me to start talking about empty bed contact times and things, engineering things. So we'll just say that if you follow the manufacturer's instructions, it should work and should take out the PFAS out of the water.
Yeah, and it should be, if you're thinking at all about a whole house system for your private residential well, then make sure that the manufacturer is considering the amount of flow that you use and potential concentrations coming in, because those are all factors into that engineering design that they would have to consider for ultimate sizing of a system.
Great, thank you. Quick reminder and a question for you. Obviously we're recording this. We're gonna post this the recording to Hoover as soon as we can. Also the slides, the copy of the slides, the PDF of the slides will be posted to Hoover, correct, Mike and Abby?
Yes.
Okay, great. So the question that we just got is, are folks allowed to share that, post it on their own websites so that folks can see this information? Any concerns with linking to that information?
No?
Great.
We just ask that you give us credit for the hard work we put into finding all the information for you, but no, it's publicly available. So sure,
Cool.
sure.
Great.
Yep.
Short chain PFAS are replacing long chain as they are believed to be less toxic. But by design, the question is, would they not be more penetrable to the human skin?
So far, not. This is one of the areas where there's a lot of research going on, and the research that I saw most recent was still longer chain things are not making it through your skin so much, but shorter chain is a good question. That is a very good question that there is research being done, and I don't have a good answer for that. We should say, what is the difference between long chain and short chain? So this is PFAS 101. When we talk about long chain things, we're usually talking about things that are 8 chain or longer. And by chain, we mean 8 carbons or longer. Short is 6 or less. So a lot of people, when they're thinking short chain, so 4 carbons, 3 carbons, they're thinking about that when they talk about short chain. So it's a way we count carbons. And so PFOA, PFOS are 8 chain carbons. So those are considered long. And things like PFBS, PFBA are short. So once again, that's just part of the complexity of PFAS is defining long and short chains.
Great, thanks. Buckle up, Joel. I'm scrolling way down here. We've talked about sampling fish tissue. Are there any PFAS studies in fruits and vegetables in Michigan?
Not per se. There's been a lot of national work done on that, but there's not a lot of published papers on some fruits and vegetables. Yes, there have been papers on soybeans and corn. I haven't seen, I think there's one on their apples, maybe blueberries, but there's just not a lot of research that's been out there that I found that's been published on it. Easiest way, get there out there on Google and type in PFAS and blueberries or PFAS and apples, whatever the fruit is that you're interested and concerned about, and then you'll find the latest research that's out there. But don't expect to find 150 papers on it. It's something that people are researching, so there is stuff going on that research on that very subject.
And I think this is a particular area about crop uptake, and it depends on the PFAS that's in the soil or the groundwater. It depends on what the crop is. It depends on the growing season. It depends on a lot of things. So you can't always assume that it's always going to be a particular rate of transfer. So a lot of, like Mike said, a lot of research going into this, but a lot more questions than we have answers at this point.
Yeah, and it can vary on soil type too. Clay soils versus sand soils versus sandy loam. So there's so many variables out there, long chain, short chain. So there's all these different variables that you'll find. So it's often difficult for us to give you a really good yes, no answer or black, white answer because there's so much gray between this.
Great, thank you.
Lot of great questions here because I know we're not going to get through all of them. I see an easy one here though, and Michael like answering this one. Are PFOA or PFOS found in elevated levels at dry cleaners or car washes that are significantly above background in anthropogenic sources?
Yes, so the answer is yes. So we'll start with detergents, things like, as I said earlier in the presentation, certain detergents to wash clothes with had PFAS in them. They supposedly do not now, but they did. Things in car washes, yes, because you have a lot of suds, you have a lot of surfactants, because you got to get that dirt and grease and bugs off the car. So you'll find that surfactants do a really great job. Sometimes back in the day, the waxes they applied, the hot wax or whatever, had PFAS in it because it would make it spread across the surface of your car, make a super nice layer. So dry cleaners, yes, for various reasons. One is that they would dry clean clothes that had stain resistant properties. And sometimes some of the spotting chemicals that they would use had PFAS in them too. So yeah, absolutely. Florida did a study and found PFAS in every dry cleaner that they looked at the groundwater and other problems. Yeah, definitely. So car washes, yes, we have found that in studies. We have found it in dry cleaners too. Yes, and we found it at laundromats also. So the answer, yes, yes, yes.
And if you look on our MPART website under the GIS layers, there is a way to filter the sites. And we do have at least one car wash and a couple dry cleaners already listed as part of our almost 300 PFAS sites in the state. So we don't have specific studies in Michigan on those, but we know that some of our colleagues down in Florida have done sampling of dry cleaners and have a pretty robust study on their results for dry cleaners. And we wouldn't expect those results to be any different here in Michigan.
Great, thanks. And Abby, yeah, appreciate it. Jump in if you see a question that you want to hit on. One question here is, are PFOS and PFOA the only types of PFAS that have been tested for potential effect on human health?
No, there are many other ones that are because PFOS and PFOA are so ubiquitous out there in the environment. That was a couple of the chemicals that were tested for in humans. There is a study out there where every couple of years, blood across the United States is tested, and those levels of PFOS and PFOA are coming down because PFOS and PFOA aren't used in the United States anymore. However, unfortunately, PFOA, PFOS are still being manufactured in other countries around the world and still being used heavily in those countries. So just because we got rid of it in the United States and doesn't mean that it's not being used elsewhere around the world or being manufactured.
Mm-hmm. And I do see a number of questions around biosolids, which we will have a presentation on Thursday morning around Michigan's biosolids. So check that one out because we won't be able to get to all these questions. And then there's a lot of questions on crop uptake. I've got a presentation on Tuesday afternoon from one of our colleagues over in Maine talking about some of their work with crop uptake in some grasses, which is fascinating stuff. So please check that one out. And I think if I can take the last 2 minutes, Mike, just to
Sure.
again welcome everybody to the PFAS conference. We're going to do a formal opening here at 1 o'clock, but great questions. So please keep the questions coming in because we're going to try to get through as many as we can, even through the Wahoo app later in the day. But there are a lot of sessions that actually touch on your questions during the next 2 days worth of conference presentations. And so part of my goal here and our goal here at MPART is that we make sure this collective conversation around PFAS, all the various parts and pieces of PFAS conversations, whether it's crop uptake or biosolids applications or consumer goods or all of those things, that we have this conversation in a really neutral setting and you guys are able to ask questions at a very reasonable cost. So that's why we've kept this virtual, because I want to be able to include people from all over the world and all over the country to be part of this conversation. So Mike Gurney, I'll send it back to you then.
Well, we should say, Mike, before we go, thank you so much for watching, and good morning, good afternoon, or good evening, depending on where you are in the United States or the world. Thank you so much for attending.
Yes, yeah, absolutely. Thanks so much, Mike. Thanks, Abby. And thanks everybody for jumping on. We'll talk to y'all at 1 o'clock for the official opening presentation with Abby and Director Phil Roos for the Michigan Department of Environment, Great Lakes, and Energy. If you're in the Great Lakes region, have a quick lunch and we'll see you at 1 o'clock. Thanks so much.
Thanks, everybody.
Thank you.